for which you don't have allocated any space is slow. This is why we developed other kinds of storage. So this is the flexible type of storing variables. And then afterwards, we will talk about fast ways to store variables. So we have the node. And the node has an ID, has 3 coordinates in space for 3D. And it has a space to store the nodal data. This is OK. Then all data is stored in variable value pairs. This is a very important concept in Kratos. You won't have a function that say, give me the velocity. There will be a function that will say, give me this variable, and this variable is velocity. So you have always pairs, velocity and the value, pressure and the value, density and the value, for example. So this is a very important concept. Then I'll go to, this is another slot that nodes have. The nodes have a slot for nodal data, which I just talked about. And then they have another slot of memory, which is much faster, to store the historical database. That means, usually in a strategy, you need the pressure of this step, but you also need the pressure of the previous step. And maybe you will need the pressure of 2 steps ago. So there is a buffer in the nodes which stores as many time steps as you want of a certain variable. So this would be the pressure at this time step now, the pressure of the previous time step, and the pressure of 2 time steps ago. And this is fast, but you have to allocate it at the beginning. The details we'll be giving later on. What happens when you go farther in time? Then you have to do a process at the end of the time step, which is to move everything one piece of memory, let's say. And what you do is to advance in time. Now you have this value of the variable, and you basically lose the track of this value. When you advance in time, you move everything, and basically you make a copy of the last value you had, and you will overwrite the new one when you have the solution. And you lose the oldest value. This is the historical database, which is completely different from the other one, the nodal data. It's only on nodes. This is only on nodes. This doesn't apply to elements or mesh or conditions, only on nodes. But it's fast and needs allocation at the beginning. So we have the non-historical database, this nodal data. We have the degrees of freedom to tell the node what variables are degrees of freedom. So they belong to the solution of a system of equations. And then we move to elements and conditions. The elements and conditions are basic for the finite element analysis. The elements centralize the information for a single finite element. And the conditions are objects that are very similar to elements, but usually have 1 dimension less. For example, in fluids, an element would be a tetrahedra or hexahedra, while a condition is a phase. It's a phase where you have applied a condition. Condition that can be a wall or can be anything. In heat transfer, there are also phases, etc. In 2D, if you have triangular elements, conditions would be lines in the segments. And these elements, here I would say this point is not talking about conditions, basically talking about elements. The element is able to calculate the local contributions to a global system. So the element contains how to calculate your mass metrics, how to calculate your damping, how to calculate your stiffness, and everything, and also the right-hand side vector. The local contribution, because the global contribution of everything will be assembled by a strategy. So imagine you want to code your finite element application, and it's completely different from a heat transfer problem or structural or fluid dynamics. But you know that you have to build a system and solve the system. Probably this is already done in Kratos. So you probably only have to program what's the shape of your mass matrix, how is the damping, how is the stiffness. Maybe you will have different names for these functions. But you will have to rewrite these functions of your own element, but probably you won't have to program anything else. So this is the element, and the element allows you to compute all these local matrices that can be assembled to a global function. The element has access to an entity that is geometry. The geometry contains the nodes. So from an element, you can loop the nodes. The geometry also contains shape functions and other values like the area, Jacobian, everything. Everything is contained in geometry, while the element only has the ID and the elemental data, which I talked about some minutes ago. Also, if you have to access to the material properties, you have a pointer from the element to the material properties. Note that there is no access from the nodes to properties, only from the element. So the containers are these. We have a container for nodes. What I was saying is an array of nodes. You have an array of elements. You have an array of properties. And you have an array of conditions with all the variables that they can store in their own memory. And the mesh, any mesh can contain several of these arrays. For example, you have a model, and you will have a mesh that contains all nodes, all elements, all properties, and all conditions. But you can create a different mesh, a sub-mesh, that contains maybe half of the nodes, half of the properties, and one condition. And you can create as many meshes as you want, and they can overlap. So the meshes are a very flexible object too. The process info is an object to store any variable to, and is accessed directly from the model part. Okay, if you want to simulate a problem, you have these three main objects that are the scheme, the builder and solver, and the strategy. Basically, the scheme is in charge of implementing time discretization. How do you advance in time? You know, usually here we put the forward Euler, backward Euler, Crank-Nicolson, Runge-Kutta, etc. The builder and solver tells the application how to collect the local contributions and assemble the big system, and how to solve it. It can be very customized. And the strategy is probably the most important one. It's the top solution layer. It controls basically everything. So you have a strategy, and this strategy is the object that is called directly from Python. From Python, you call the strategy. The strategy, solve. And the strategy will call the scheme, will call the builder and solver, will call everything. Okay, how much do I have left? Negative time. So yeah, you have the solving strategy. You can derive it and create your own. This will call the builder and solver, or you can customize it. It will call also the scheme to advance in time, or you can customize your scheme. And basically, this is the aspect it will have inside the strategy. The strategy will have this aspect. The processes and utilities are functions that can modify the data directly. You can write a process that is capable of rotating a whole structure, or multiplying pressure by 2 everywhere, or you can create an utility that basically does similar things, where when you don't know where to put a function that affects the memory, you can put it in utility. I will skip this. And Python scripts. I already talked about this. Everything is implemented in C++ except the more general things, and the solution process is controlled by a Python script. There is some available Python scripts that are prepackaged solvers. And this is the end. Global workflow, introduction for the next talks. Once the Python script, the general Python script is called, the first thing is to read the information from the input files. You read the nodes, the elements, conditions, nodal data inside the nodes, elemental and conditional data. You read all of this, and the Python script does the following. Import the Kratos, and it means to import the C++ libraries, compiled libraries. Import the solvers that you will need, and usually the iteration over time, the temporal loop, is in Python too. Okay, thank you for your attention. Any questions? No hay cable aquí.
Seems as I have some problem with the connection. I don't know what's happened to it. No. Saying that accessing to internet, but que no tengo esto es de Wiki. Lo he puesto, tampoco va. Actually, I don't know what's happened. ¿Alguien tiene? ¿Tú tampoco tienes? Miguel Ángel, ¿tú no tienes el acceso a internet en tu portátil? Eso es lo que hice.